Good afternoon, everyone. We are happy to invite you here to participate our sessions here. You know that the PID is the instrument for the open sharing of the scientific data. And our session is mainly to address the challenges about so many PID standards and PID systems here. So how to converge and interworking with different PIDs here is very important, especially when the AI is coming and the scientific data is increasing in a knowable place. So today we would like to have some presentations to share, especially the use cases of using the double identification SSTR to connect the national and international to make our scientific data more adopted, more sharing by the worldwide. So let's start our sessions. First, we will invite Xiaoli to give the presentation. So Xiaoli, are you on?
But yeah, I'm happy to start our session as the first presentation. But I would like to thank our convener, a colleague from CINIC, to organize this session. I think this is a very interesting topic that we really want to discuss today. And thanks everyone for joining us in the room. My name is Chen. I work at DataSite as a project leader. I lead a project called Implementing Fair Workflows that focus on implementing a personal identifier workflow across the research project lifecycle to ensure everything's discoverable and interconnected, so as to say fair. That's very related to our discussion today. And I apologize first that I'm not in the room. I originally planned to travel to Brisbane and really regret that in the end it didn't work out. But I hope everyone in Brisbane is having a great time. So yeah, as I said, my role here is really to set the stage and give some wider context to the main topic. So like that, we all know that adoption of PIDs is never a uniform approach, and it's always have to adapt to the local context, the local requirements and use cases. In this particular case, is the innovative application of the double identification in the national level research infrastructures. So like the speakers after me is going to give detailed description, in-depth introduction to that. So I will keep my talk on open PID systems very short. I would just like gloss over some of the effort that we have spent on opening up the global adoption and the efforts we make through our capacity building programs. And I will talk on these couple of topics: the PID system membership model and like our global reach and the efforts towards global adoption and the DataSite global access program. So we start with general review of the prominent open PID systems and their membership. We all know that over the past 15 years, end of 2025, it feels like quarter of a century in, we're past 15 years of developing personal identifiers, and we see the emergence of several key PID infrastructures. This conceived and established by our scholarly communication community. And we have the researcher identifier ORCID, now that it has 1,200 membership organizations across 150 countries, extremely prominent. The ROR organizations registry with like 110,000 plus research organization globally that is recorded on the registry, and the two main DOI registration agencies in the scholarly work domain, Crossref with 23,000 members in 163 countries, and DataSite with 1,600 organizations in 64 countries, respectively covering basically all types of resources and outputs produced in scholarly communication. And then we have, last but not least, the RAID identifier, the research activity identifier that is developed, and the effort spearheaded by our organizer this time at the ARDC, Australian Research Data Commons. I didn't find like a specific statistic, but RAID also operate on the membership model, and I believe many local Australian and North America organizations already started implementing the RAID identifiers. So yes, membership model and the continuous growing numbers here, we already showed that the community is embracing the value provided by PIDs and open infrastructure. As we all know, open infrastructure, the value grows as the community grow. This is like the benefit is exponential as new metadata as resources come in. And with this open infrastructure and the benefit clearly established, the global community has made concerted effort to draw up blueprints for adoption on not only institutional but also on the national level. So led by our colleagues at ARDC, the National PID Strategies RDA Working Group collected and shared valuable experiences from their own adoption and implementation processes, and they deduced a set of actionable recommendations around an agreed upon set of common person identifiers. And in these deliverable, we can already find probably in this new RDA resource hub website, the deliverable include a strategy guide and checklist as framework for a national implementation from 9 case studies from 9 countries. That the upgrade core set of identifiers are the ones that I mentioned in the previous slide. And there is some like encouraging emerging patterns that so like with these implementations, we expect them to, and we've seen them being used to reduce administration burden, to enhance discovery, and to improve assessment. So being the representative from DataCite, I want to highlight the incredible work done through the DataCite GAP program in past year. That's our global access program. So GAP is a program designed to support organizations from underrepresented countries in terms of PID adoption and the regions to enable their their research outputs to be discoverable, and specifically it targets nonprofit organizations in Africa, Asia, Middle East, and Latin America to take up the mantle in their respective regions to raise awareness, advocacy, and even build the infrastructure for PID adoption. The DataCite blog actually continues to report on the GAP projects and their posts about the past projects. So through this program, we have funded 3 categories of projects that include outreach activities, infrastructure development, and demonstrators. That's like a big project that's good for establishing value and translating the value of PIDs in the local sense that makes sense for the community we're serving. So like in 2003 and 2023 and 2024, we respectively funded 12 and 8 projects out of 300-400 applications, and in overall we funded 20 projects across 4 continents, and some very prominent success stories. We're extremely proud of these projects. Our work is completed. that include the OpenScience.ge repository by the Georgia National Science Library, the Amazon Climate Data Infrastructure built by the University of São Paulo, the Open Science training across the Middle East. This is like a tremendous effort taken up by the Arabic Center for Social Sciences and obviously our partner at EcoConnect built the Enhancing Research Visibility program in West Africa. So similarly, our sister organization, Crossref and ORCID, also have long-standing programs to support capacity building globally. Crossref has the Global Equitable membership programs. They offer relief from membership and content registration fees for members in the least economic advantaged countries in the world. And we have ORCID Global Participation Program that supports ORCID's efforts to bridge the participation gap and improve equity of access to interconnected research infrastructure in currently underrepresented regions. And I encourage all audience members to review this program on their website, on the Crossref and ORCID website, and learn about their profound impact over the years. So just in my very brief presentation, I guess the key takeaway is PIDs are really essential infrastructure for research. Nowadays, that's very digital and AI-oriented. National strategies to accelerate and adoption while maintaining global interoperability and equity initiatives like GAF and a global equity program ensure no community is left behind. And in this sense, some calls to actions. Please consider adopting PIDs if your organization has not already done so. Support your national strategies. If there isn't one, start one or start a conversation of one. And obviously contribute to capacity building programs in terms of financial support or expertise sharing and shared knowledge by joining RDA groups, attending events organized by DataSet or any other PID organizations. So, and go back to the topic of this particular session, we DataSet will commit to support PID implementation approach that meet the needs of the community the member organizations serve. On top of that, we commit to contribute to continue the collaboration with our sister organizations and support global communities through initiatives and wider open data and open research community like the RDA and CalData. Together, we'll work towards the realization of connected and openly discoverable research. So that's my opening, and I will give the floor to our speakers.
Thank you, Xiaoli. Thank you so much.
I think we will take questions at the end of our presentation.
Yeah.
And if anyone is online, please put your questions in the chat. We'll get to them in the end. Okay, so we will make to finish these 4 presentations, and after that, we will have the Q&A and maybe a panel discussion. So I will give the next presentation about PID infrastructures in China for the open data sharing. So my name is Jia Liu. I'm coming from the Chinese Academy of Science Computer of Network Information Center. So our team is mainly responsible for the PIDs in China. That is called the CSTR. So because just like Xiaoli said, that PIDs is a very essential basement for the open sharing of the data. So the UNESCO has released a white paper that said the PID is the first time as the key component of the open data sharing infrastructures. So, but as we can see that there is not just 1 or 2 PIDs in the world globally. So we can see there are different various and distinguished the PIDs around the world. And for the DOI, it's mainly for the literature and papers, or CAD is for the authors, and Handle is the ITUT standards that is for the
basement of the resolution systems, and there are also the other P's around the world. So P's is not just a simple numbers. Behind the P's, there is a very important systems and service platforms. That is very important basement for the users to use the P's services. So what is a CSTR? Maybe someone is very familiar with this piece. So the CSTR is short for the Common Science and Technology Resources Identification. It is one of the national standards of China. So it is published in 2016. In the CSTR, it's a different identifier that classified by different varieties of the science and the technology resources using the 2 digital numbers in the middle. So here is an example of the CSTR. So the prefix is composed of 5 letters, and 11, that is the tab number of the resources, is for scientific data. We also have the other tab numbers, tab code. For example, there are 2 is for the major science and technology infrastructures, and the 14 is for the papers. That is all explained in the China national standards here. So for the CSTR, based on the China national standards, we released and developed a service platform, and also we released resolution systems that is based on this CSTR. And CSTR is free to have, so you can have the basic services from the CSTR for free, and it is easy to use, adapted to the literature, to the data repository, and in the API services. And also you can upload your original files to get the CSTR. And the CSTR, another typical of the CSTR is it's not only for the digital resources, it's also for the physical resources, just like the instruments, like the species. So this is the CSTR platform, and this is initiated in 2018. That provided CSTR services not only in China, but also for the world. And right now we have integrated with the APA, that is the Africa PID Consortium. So for the other countries, they also can apply for the CSTR identifiers using this platform. And after you go to the CSTR, how the CSTR can provide the services to the users is very concerned by our customers here. So the first we provided the basic services, that is the registration, resolution, and reach. Metadata sharing, and this metadata will be harvested worldwide to improve the data to be accessible, findable, and usable. So that is enriched online CSTR statistic and the presentations, and also the resolution here. So we also have the service and especially the citation services. We have provided the CSTR services for the China National Scientific Data Centers up to 17. And all these data centers, they will receive the citation report annually or monthly to see how many registers has been P's assigned to, and the citation is from which paper, or the resolution is from which countries. So that is very essential for the scientific data centers to evaluate the value of the scientific data, which one is the best concerned. That is the most concerned services that provided by the CSTR. And also the CSTR is now not on mainly national standards. It's also adopted by the IANA, that is the one of the IEEE standards, and the DOI is also included here as the IET of IANA. And also we have incorporated with ORCAD, FAO, and now we are participated in some coordination institutions to attract up to 368 institutions to adopt the CSTR as one of the most important standards of the PEAS. So I will show some use cases from the CSTR. This one is for the national data centers. You can see their list. The national data centers is widely used. The CSTR is widely used by the national data centers here. And also they will place two P's. One is from the DOI and the other is from the CSTR. Why they will do this? Because the CSTR will make adapt to the national policies about the scientific data management. And for the DOI, it's mainly for the open sharing and for the open science. And next one, we integrated with the National Advanced Platform. This platform is on the national level to provide the PEAS and the CSTR, and also the DOI for the scientific data to advance the sharing of Chinese scientific data societies. So this is for the journal and articles, especially for the scientific data journals. As we all know, the journals is not just one item. The content in the journals attracted from these papers will be assigned as CSTR, just like the algorithm, the software, or the sentences, blah, blah. So this is for the preprint. This platform is called China Archive. That is very famous, the preprint platform in China, and all the preprint will be assigned the CSTR, not in the one exception, but they will have different CSTRs according to the change of these members. So this is for the physical items. This is a China species list. So for the China species list, they will update annually. So they will adapt the different CSTR for the new species. And for each species, they will have the typical plant in the national park. So we will print the 2D barcode and put it on the typical plants. So when the users in all the tourists and all the plant workers, they using the special handphone or special 2D barcode scanners to scan the 2D barcode, they will got different informations. For example, if you are tourism, you scan this 2D barcode, you will get some very common information about this species. So if you are a worker in this national park using scanners to scan this 2D barcode, you will get the listed information about where does this plant come from and the year or the other specific information of caring about this typical plant. So if you are interested or the very contributors, you want to make some information inside this 2D barcode, you also can make it using this SDR. And the other one I would like to share is that we have using the CSTR in the large research infrastructures. Currently, we support up to 400 facilities and related requirements. You would have the relations between the facilities and the related equipment. So this is already used in the literature, and monthly we will go to the citation about up to 200. This information is not in the citation of this literature, it's mainly in the acknowledgement. So if you use the SCI or the other engine searchers, you can track this information from the platform, and you can see there is a specific SSTR mainly to each research infrastructures. That is very interesting because before this interconnection, we have two big platforms. The first big platform is for the Sun Engine, that is the publisher platform, and the other platform is for the CAS, the large research instrument platform, that is for the researchers to arrange their experiment. So when they use the CSTR, they link the output the output scientific data, the output the literature, and their experiment, and the scientific data that derived from the experiment. That is the link of the CSTR services. So we also provided the other services, and that is called a node. The node is especially the same as the handle node. So the CSTR is not a single platform. It's based on the CSTR resolution systems. And this resolution systems is not an integrated system. It's a decentralized platform. And you can install this software in your country and management your own data. The data can be managed by yourself, but can be shared globally. This is welcomed in different countries like Malaysia and the Asian node. This is in the other Belt Road initiatives. And also the CITR is the key components in the GOST. We held this meeting or workshops mainly focused on the PIDs every year, and I think this year maybe this workshop will be our the annual workshops for the PID discussion, and thanks for the organizers of the read, and we can come here to in person to make very confluent communications here. So for the double identification with data site, here is an use case from the Science Data Bank. The Science Data Bank is the common repository from China that is almost the same level to the Figshare of the Zenados. So we use two different identifiers because for each scientific data site, they will include many files or many documents. Their documents also be assigned with SSTR that has a different suffix with the data site, but related with this data site shared the same prefix. So we would like to build and contribute to the peace society to work closely and seamlessly integrated with the ORCAD, the data site, and the DOI. And right now we have always working on the integration with the data site, because in China, most of the scientific national data centers will use DOIs, and the data site DOIs will provide the very fluent and good and very useful services. So we would like to see that for our users, they will just apply for once and they will get two identifiers to upgrade and to improve the sharing of their scientific data. This is just an example from the Science Data Bank about the files and related data sites to trace the whole life cycle of this scientific data and the files included in it. So this is our website and the feedback code. So if you are interested in getting the CSTR to cooperate with the CSTR, please contact us. So that is all I will share today. Thank you so much. Okay, as I'm also the moderator of this session, let's welcome the third presentators, that is Xiaoli. Thank you.
Okay, thank you, Liu Jia. Good afternoon. My name is Xiaoli from the National Space Science Center, Chinese Academic of Science, and I'm very happy to give this presentation, the user's case of the PIDs from the National Space Science Data Center's practice. So in this presentation, firstly, I will to give a basic briefly introduction about the NSSDC, and I will talk the current data creation practice with the PIDs. And after that, I will talk to what are we going to do towards AI for science. So now about NSSDC. So the NSSDC is the national level space science data center recognized by the Ministry of the Science and Technology and the Ministry of the Finance of the China. The domain scope ranges from the space-based, space physics, space weather, space astronomy, planetary, space earth science, space engineer, and space applications. The mission statement of the NSSDC is to facilitate the governance, high-quality construction, and open sharing of space science data, and to develop ecosystems for the innovative application of space science data, and to explore data-driven paradigm changes in scientific research and improve the utilization of the space science data. So the host institutions of the NSSDC is the National Space Science Center, CAS, and we also have some of the co-construction institutions, include the National Astronomical Observatories, CAS, University of the Science and Technology of China, National Time Services Center, CAS, and the Computer Network Information Center, CAS. So the NSSDC was founded in 1899, and we became the regular member of the World Data Systems since 2013. And we also certificated by the Co-Trust Seal since 2021. And NSSDC also is recommended by some academic groups like the AGU, SVIL, and Springer Nature. So NSSDC participated some of the national major projects from the space science satellite missions to the ground-based observations networks. So of course, we archive the data from this kind of the project. So this is the systems data resource the NSSDC hold. Currently, we manage more than 3,300 scientific data sites, and we built 37 domain databases, and the data volume exceeds the 3.3 petabytes. So now I'd like to talk the data curation process with the PIDs. So currently, the application of the PIDs is embedded in the entire workflow of the NSSDC. So this is a framework of the data curation workflows we designed based on the OAIS models. As you can find at the beginning of the workflows in the ingest stages, a PID number is assigned to the dataset, and along with the pipeline of the management, storage, and access. So we will do some of the internal data provenance according to the assignment PID numbers. So once we release the data, the PID will be registered, and analyzable PIDs will be used to the external data provenance. So normally we will use some the third-party platform like the STR identification platforms to resolve this kind of the PID numbers. So the PID used by NSSDC include the DOI and the CSTR for the datasets, and we used the RSIDs for the researchers. So normally we will implement the PID registrations through the dataset, through the CNIC, and through the OneFund platform. Actually, the PID numbers is located in the metadata field. So this is the framework of our metadata. We have two kinds of the metadata. The first one is the co-metadata. Normally, we use the co-metadata to interoperate it with some common metadata like the dataset metadata, like the Dublin course metadata. And we also have the domain metadata, which interoperated with some space science metadata, like the space, like the VO table, like the BDS full. This is our core metadata, which consists of the 28 elements. As you can find, the DOI number, the CSTR number, and the ORCID number, they are one of the elements in the core metadata. And this is our domain metadata, which consists of the 8 entities and in total 192 elements. As you can find, this have a different kind of the identifier in the different kind of the entities. Like for the data sites, we have data sites identifier. Like the document, we have document identifier. Like the repository, we have the repository identifier, and we also have the instrument identifier, observatory identifier, person identifier, and parameter identifier. We use these identifiers to connect the different entities in our domain metadata. So this is an interoperative framework of metadata, and the NSDC metadata include the core metadata and domain metadata can be mapping to the different kind of the desampling or common metadata. And the interoperated will be achieved through the harvesting of some registrations. So when we republish data, normally we will give the two kinds of the identifiers. One is CSTR, China National Standards, and another one is DOIs. And we also will give the Creative Commons license, and we provide the data citation information. And we also will synthesize the results of the citation based on the PIDs. So now I'm going to talk what we're going to do for the AFO science. So as we know, we are entering the area of the AFO science. So now we are developing the AI-ready space science data. So normally, when we receive the original scientific data, we will do the cleaning, we will do the accumulating and organization to become the basic scientific data. And for the basic scientific data, we will do the deconstruction and recombination and to become the semantic data products. For the semantic data products, will be annotation, will be give some label and become the semantic annotation data. And for the semantic annotation data will be correlation and alignment with the knowledge. Then the data become the knowledge base. So this is the list of the example of the AI-ready space science datasets we developed. So this AI-ready datasets means we give some the labels for the physical events like the solar active regions or like the auroras. This is another list about the AI-ready space science data and the data resource from some of the ground-based missions and from the Chinese mission, Chinese Mars missions. So besides, we also develop a domain intelligence applications tools along the space weather event trends. And the kind of the type of the intelligence application tools include the event recognition, feature extraction, knowledge discovery, and evaluation modeling. So let's back to the PIDs. We believe the PIDs are not used for the data, but it can be used for the knowledge. So for the next steps, we consider use the PIDs to associate the label physics events with the knowledges. And we believe the PIDs will be play a very important roles to connect to the sorry. Hold on.
Power of the AFO science, right?
So it's my last slide. So what I want to say is next steps, NSDC will try to some practice, try use PIDs to connect the data with the knowledge that we are gonna to do in next steps. Thank you. That's all my presentation.
Thank you, Xuqi, for the presentation. Yeah, so let's welcome the Satoko to, yeah, maybe you can go on the floor first and introduce the presentations first. And when the power is back, and we can see your slides. Oh, right, thank you. We got it. Thank you so much. Perfect. Oh, please make the door open. I think when the door is open, the power will come in. All right. So thank you.
Good afternoon. I'm Satoko Fujisawa from Japan Science and Technology Agency. We serve as the Secretariat of Japan Link Center called JARC. It's a DOI registration agency in Japan. Thank you for inviting this JARC to this session. Today, I present the technological and community-based approaches to metadata infrastructure for research data, focusing on DOI. Okay, let me begin with a brief overview of JARC. JARC is Japan's DOI registration agency, accredited by DOI Foundation in 2012. And JARC registered DOIs for academic content produced in Japan or in Japanese. JARC DOIs account for 3% of total DOI in the world. This slide outlines the organizational structure of JARC. JARC, jointly managed by 4 governmental institutions, JST, and National Institute of Material Science, and the National Institute of Informatics, NII, and the National Diet Library. JARC provides the DOI services directly with the DOI Foundation, and at the same time, JARC is a member of Crossref and DataCite. And the membership structure of JARC includes 2 tiers, regular member and associate member. Regular members are platformers, so they are registered DOI through their platforms. And the associate members are users of provide services provided by regular members. So they register DOIs through the platforms of regular members. For example, JST is a publication platform, and NII manages institutional repositories for universities and research institutions. Some JARC members are National Research Institute, which conduct the advanced scientific research or publishes of English journals. However, most of the associate members are local universities and small academic societies and publishers. So a significant portion of JARC's content and metadata are in Japanese. Then JARC is optimized for domestic needs. This shows the flow of metadata distribution in Japan. JARC is a part of that infrastructure. The JARC's role is aggregating the metadata to be registered DOIs from the various sources and provide them to the metadata services like Xiaoli. So it facilitates the access to the Japanese academic content. So the graph shows the growth of the number of DOI, JARC DOI in Japan. The growth of the DOI registration in JARC. As of August, it accounts about 40 million. In JARC, research data is one of the 5 content types, so yellow part of this graph. So the DOI registration for research data has been increasing over the years corresponding the growth of the importance of open research data. JARC designed the metadata schema for each content type. And in principle, metadata for research data is defined conforming to datasite definition to ensure the compatibility between the JARC and the datasite. So JARC for the datasite schema update. Currently, we support schema 4.6. And research data is becoming to cover more general resources according to datasite update. For example, JARC will cover preprint as research data, and JARC will cover grants in manner of datasite. But on the other hand, JARC's research data doesn't cover resource type equivalent to journal article or books because they have other schemas compatible with Crossref. And as an infrastructure for metadata distribution in Japan, JARC aligns national policy. National policy on promoting open access to publicly funded scholarly publications and scientific data was approved by the Cabinet last year. This policy mandates immediate open access to peer-reviewed publications and research data, underlined publications resulting from publicly funded projects. And also, the government defined the common metadata elements for research data. Then the JARC expand the content type for covering these metadata elements. Besides the technical support, we support the community activities through the event, the seminars, and mail magazines. As a part of community building, we support a research data utilization forum called RDUF. RDUF is a Japanese community that facilitates a discussion to address the issue of research data sharing. The main activity of RDUF is holding the event like a symposium and their output-oriented working groups in manners of RDA. One of the output of RDUF is the guideline for the DOI registration for research data. The guidelines are a revision of the version published 10 years ago. The guidelines offers comprehensive and accessible explanation regarding to DOI registration, such as the basic information about the JARC and the DOIs, and the principle underlying the DOI assignment, and the procedural aspect. And also it includes the best practices in the research institutions. Much of the content can be common with DOIs beyond JARC and will be useful to many readers. The English version is available on our website. And today I have some copies, so if you'd like, I gave you. Okay, so as far I've talked about the domestic aspect. So in the next part, I move on to the aspect of promoting global metadata sharing, focusing on the DOI registration in datasets through JARC. JARC supports members in registering DOI with Crossref or DataSafe if they desired. So JARC's members can register Crossref DOI or DataSafe DOI within their JARC membership contract. And all the metadata is stored in JARC and it's distributed to Japan's information networks. So JARC chooses whether to datasite and whether to datasend Crossref depending on the content type. So journal article and books are Crossref, and research data is to datasite. Example of metadata to datasite is, for example, the data on global research areas, such as marine science or climate research. As of August, over 70% of DOIs are registered as JARC DOIs, and about 9% of DOIs are registered to datasets through JARC. And most of dataset DOIs are registered by National Institute for Fusion Science. Now NIFs graduated from JARC and they became the DataSite direct member. This graph shows the flow of the DOI registration to DataSite through JARC. JARC organizes the JARC consortium as a member of DataSite. And currently we have 10 consortium organizations. On the first step, JARC members deposit their metadata to JARC with JARC schemas. And on the next step, JARC converts them into the DataSite schema to deposit to DataSite. So JARC's members only need to follow the JARC schema. They don't worry about the DataSite schemas. So it's much easier for them than direct registration to DataSite. And the advantage of this model is not only for the registration, but only for the data sharing. All the metadata is stored in the JARC system, so harvested by the Japan's scholarly information search services like Xiaoli. And at the same time, the metadata is stored in DataSite and harvested by various global services. But there are some disadvantages. For example, some time lags for translating the schemas to catch up the latest DataSite schemas. And as I mentioned in the previous part, JARC doesn't cover resource type equivalent to journal article or book. So some advanced users might be frustrated with this advantage. So I wrap up with our current and ongoing priorities. We are aiming to maximize the fair principle of JARC content. It includes providing metadata registration functionalities, considering both registration and sharing aspects. So we continuously update the metadata schema to ensure compatibility both with other PIT services and to respond to national policies. Also, we provide metadata registration support through manuals, registration interfaces, and guidelines. And another key priority is expanding the API capabilities to promote JARC's metadata harvest. Currently, all the content of JARC is harvested in Open Citation Index and in the process of being harvested by multiple global aggregators, including OpenAir. Okay, thank you.
Thank you, Satoko. Thank you all the presenters, including me, for the presentations. So I would like to hand over my microphone to the Xiaoli. So would you like to change the slide to the Zoom? Hi, Xiaoli. Are you online?
Hello. Can you hear me?
I would like to turn the floor to you.
Right. Thank you. So yeah, we had 4 very interesting presentations, and thank all the speakers. And we've heard about diverse approaches to PID implementation on different scales and context. So in the following parts, I would like to help the room facilitate some discussions or answer some questions. So I can't, from my camera view, see the room, so I don't know if there are any question in the room that we want to address first. So if Jia can help me with that, if there's hand raised in the room, we want to do that first. If not, I have a couple of questions and discussion topics that I want to introduce.
So any questions? Yes.
Thank you. My name is Fiona and I'm from UNSW in Sydney, Australia. You mentioned programs to reach underserved communities and other research groups. I'm very interested to hear about how non-research institutions are part of this puzzle. So, for example, NGOs and other organisations that produce research but are not themselves research institutions, how to ensure their work is discoverable and part of this big landscape.
Okay.
Yeah, this is a very good question. So when we started talking about the Global Access Fund, we were completely open to any non-profit organization, even if they are not researchers or the host researchers themselves. So they still fall within the scope of GAF, and they have the opportunity also to submit their applications. Yeah.
Thank you for our audience to ask and answers. So any questions here? Maybe Xiaoli, do you have the questions? You said you have a few of the questions here.
I have back up in the room and a colleague Mohammed, who's overlooking the GAP program. So he'll be the best to answer that question. Thanks, Mohammed.
So
any other questions from in the room?
maybe Xiaoli, you start first for the questions.
So yeah, then I will moderate it a little bit. So first question I actually have for our set of speakers is how do researchers in China and Japan respond to having both local and global PIDs when sharing or citing data? So do you have education and support strategies that you develop to promote the implementation of PIDs or usage of PIDs in their research projects?
Yeah. Xiaoli, we can only hear your voice, but no images. Our screen is powered off.
Is that?
Yeah, I think we can put forward our discussions here. And you mentioned that educational project to support this. Oh, right, you are there. So you asked about the education project for the use cases, right?
Yeah, for the researchers community.
Yeah. I would like to introduce that in China, we have some national projects for the implementation and disciplinary researchers on scientific data, like the data management and the AI for science, and the other network and the information infrastructures for the national projects. And as the basic instruments and the key component for all these national projects, they will get supported by the national projects to facilitate the scientific data. Will use the very steady and very trustful the PID services. So in last year, we also got the first national projects for the persistent identifiers. That is the first time in this program. So I think that is a very beginning and a good news for us to get a loan to distract from different disciplines just for the basement. But there is also the challenges in China because the piece in China is just one component of the instruments. As you know that for the AI for science, most of the other workers is not very focused on the piece. So we are not the main actors here, but if you lack of the PIDs, maybe something will happen. So that is the essential parts of the PIDs in China. Thank you.
Yeah, thank you for the comment. And does Satoko have some comments in this situation in Japan?
Today, In my today's presentation, I focus on one aspect of double identification. I mean, the relationship between the national DOI and the global DOI. But when looking at the PID more broadly, Japan has very unique background where the domestic DOIs for the researches or research projects were established and widely adopted. And one of the current issue or challenge is how to connect them with the global PID like ORCID. So yeah, I'm from JARC, so I focus on DOI, just DOI, but that issue is more big challenging. So in that context, the CSTR, the identification is really insightful. So I hope to continue the discussion with you.
Yeah, thank you for the comment. Definitely, I think the fact that there are regional RAs and national level RAs in the APAC region is an interesting challenge and also a unique opportunity for us to promote equitable adoption of PIS and like as both of your organizations part of DESA's APAC expert group and as a convener of that group for the past couple of years, and this has been an ongoing discussion we have been having, and how to take most advantage of the infrastructure that's available to us, and to create the interconnectivities and the opportunity for interconnectivities. So it's fair to say this session is kind of a brainchild, like a fruit bore from this ongoing effort. And so, following this, what you just mentioned about connecting different types of identifiers. I wonder if you see there is different aspects of paid adoption with a more locally oriented, like a local infrastructure, locally supported infrastructure, and a global an infrastructure like cross-sectional ORCID. So does this help this double identification scheme? Does it motivate researchers to embrace data sharing in domains that are not traditionally very aware of, or have the practice of data sharing? So does it make it a smaller barrier than having to commit to a global standard that is kind of developed or started by disciplines like, I don't know, space science data or like physics, that this kind of communities are very globally collaborative, and they very easily can jumpstart a wider scale global standard. Do you see something like this when you implement local job DOIs and CSTR?
Thank you, Xiaoli. I think that is a very good question. And we are talking about, that maybe 5 years ago, we are talking about the interaction between different types of the Ps. In my opinion, that I think the interacting between the Ps is just like the different languages between different countries. And most important is the different policies. It's like a bridge to different policies of the scientific data management, of scientific data open sharing, because in different countries, as Satoko said, in Japan, they released the government fail in last year to support the Ps metadata share for the open sharing. But this is the local policies. And in China, we also published some policies to support the CSDR. So different countries in their own countries, they can manage it in their mind. But the scientific data will transfer and widely spread from different countries to the other countries, to how to make the scientific data to transfer seamlessly and fluently. That is the very important thing I think the PIs should have to solve. So I think that is a very good question, and I think maybe it's not just for the project support, it's not just for some workshops or for some conferences, that we should know the representatives of the PIs providers, the users, what they are thinking about. Is there any challenges that they are using different types of the PIs? Because I know that Xu Qi, she is the representative of one of our national data centers. In China, we have some national projects or national policies, regulations that side you should submit or some clasp your scientific data and assign a CSTR to it. If you could not assign this CSTR, it is difficult for the governments to calculate or to management to know how many valuable the scientific data is. But for the open sharing, we need the DOI, and this is why we need two different identifiers. So maybe Xu Qi, could you share some challenges or some advices or some requirements in the role of in the view of the users of the PIs? So would you give some advice to how different PIs can work together to provide better services for you? Thank you.
So for our data, when we create the metadata, we need to describe it from the instrument. It's from the national projects. It's from the researchers. It's the research teams, and it's the parameters. And we hope we can use one of the PIDs, maybe CSTR, maybe DOIs, and to identify these objects include it's the source. It's the source is from the project and the person, and maybe the data with some processing tools. Maybe the data needs the documents. We hope we use the identifiers to connect all of the informations in metadata. And in the future, we also hope we need to make the alignment, or we need to make the recoloration between the data and the knowledge. So we hope the PIDs can be connect some of the knowledge, some of the information in the data connected, and it can be clearly connect to the data knowledge, connect to the knowledge base, and it can be make the machine or make the AI knows there's some the information, there's some knowledges in the data connect. So that's maybe a very challenges for the PIDs. That's all my needs. Thank you.
Thank you, Xu Qi. That's the true thinking from our users. So what do you think, Xiaoli?
Yeah, I think it's a really interesting idea to use PIS for knowledge or concepts, and I can already see in my head like that will be a new resource type, control the vocabulary in the data side, metadata schema, and that will trigger a massive discussion in the metadata working group. But but definitely just the way that is not that is person identifier can be nested into the metadata record of different types of objects. That's the strength of this standardized approach that we take, and that is precisely how this interconnection can happen. And I look forward to see how this will work out. Obviously, all of the communities, scholarly communities that we support, come up with innovative use for identifiers all the time. It's really exciting. Right, and so another point I want to point out is impact measurement. I think a lot of the consideration towards person identifier implementation is to collect richer metrics, data metrics, and to demonstrate data sharing and the value of data sharing and reuse. So with more than like multiple PID systems implemented, there is potentially give you a lot richer metrics that you can use for demonstration or for reporting. So does this approach help you meet different impact measurement scenarios? So we want to hear your stories.
Yeah, so I would like to share that in China, maybe it is maybe in the view of Xuqi, it is difficult to adapt to different parameters or the tools that is provided by the different PIDs providers. That is what we are talking about before, that is there and possible to provide an API to provide the two identifiers to our customers to make them easy to use the PIDs. So that is the right now circumstance in China, but I think that is not, it will not solve this problem. It just solve the current challenges here. So looking forward to the health development of the PIDs society, I think maybe some high-level discussions will give some frameworks of or some suggestions or some white papers in the view of the users, not in the view of our PIDs providers. You mean that the last time in the RDA that we talk about how about the instruments, should they use the RR or the DY or some other PIDs? I think in this session, we do not involve so many instruments managers or instruments researchers here. So we just in the view of ourselves, not in the view of our customers. So maybe some other talks should be released to very widely spread, to listen to different opinions about our PIDs, and especially in AI. Should AI will enhance the PIDs services, or the PIDs will enhance the AI? That is a very good question. Maybe they will solve this problem. Yeah, that was my opinion. So yeah, there's other thinkings about this topic. Yeah, okay.
Thank you. I'm very interested in this topic of impact. So we see many of the funders are exploring what does impact mean, whether that's for society or policy or industry. But one of the big challenges is, of course, we would like everybody to use persistent identifiers when they refer to other people's work and so on. But a lot of impact comes through meetings, conversations, personal connections, and very disconnected use. So how do we include both PIDs but also very fuzzy or natural language approaches to identify different elements of impact that might happen a long time in the future? It's a big challenge.
Thank you much. Xiaoli, please.
Yes, definitely. That's a really good question. I feel like in this domain, what PID and metrics derived from PID metadata really is one, not even the most important aspect when it comes to impact measurement, but it's a concrete and quantitative like ground upon which we can make assessment and evaluation fairly and transparently, and all of this other interactions like networking, which is like also a cornerstone of any scientific endeavor. Science is a social social endeavor. Definitely, all of this is very important in building a robust, connected research ecosystem. But I think, but it's hard to look at the big picture if you only have that qualitative aspect of it. I don't have an answer to how kids can kind of facilitate or support, and in that aspect, maybe I can think of some topics we have discussed before using PID to identify conference like IDW and the contributions to conferences like this, and having people, researchers, their own profile linked to their contributions and to the organization or content of social gatherings and academic conferences like this. But I mean, I think the communities welcome this kind of discussions. We can figure out a way. But yeah, I agree. There's definitely a gap and something we can work towards.
Yeah, thank you, Xiaoli. And I would like to make an addition that is for different types of the Ps, we should provide the integrated services are very difficult things because we have different business modules or services paradigms. But maybe that one day we will have the how to say the community or some rules that we can collaborate together. And as you mentioned about the IDW, the conferences, that is the link between the person to the output and input activities. And maybe the read is the better for the activities. But here is another questions about the privacy protect. Because if you link everything together for the open sharing and for the research, that is perfect. But if you link the personal informations of all the other privacy informations of the scientific data, that is questions that P's should solve and then pay attention to. I think that is why we use different Ps in different situations, because I would like to share in China, we use the CITR not only for the open sharing, but also for the management for different department of the governments. I think maybe the same in Japan and in Australia or the other countries, because as we hold this session for the open sharing, that is good, but if we use it to a very big, widely spread area, we should pay attention to the attention of the privacy. Yeah, Xiaoli.
Thank you for that comment. I definitely agree. We should be very careful around private information. And okay, so with an eye on the clock, I have a final question for our panelists. I think we go back to our topic is around equitable adoption of person identifiers, and we've seen cases of like a shoestring implementations and very elaborate state-sponsored projects to implement infrastructural support for person identifier. So like this implementation effort really ranges very wide on like to very wide spectrum to like the cost or how much resources is invested into it. So I want to so like but we can see you can do it both ways. You can rely on capacity building programs like GAF and GEM to start your PID implementation, or you can, like CSCR kind of build a national level infrastructure that support not only in China and also like in Asia through this node schemes. So I guess my question is, what advice would our panelists give to institutions that are considering PID adoption if they haven't already and what key aspects they should pay attention to when it comes to implementation. Yes, for all of the answers.
Okay, thank you. So that is your final question, Xiaoli?
Yeah.
Yes. So is there any answers from the audience? Yeah, maybe Sakura? No? Yeah, we all totally agree with you for the valid implementation of the Ps. So I think we have already held these sessions and have a rich talk about this session. Xiaoli, do you have another or the other questions?
I have questions, but I feel like I should. I'm very interested in this ontological knowledge model that Xuqi have raised about AI-ready data products.
Yeah.
But I feel
maybe
like
next time.
think her privately about it. But I mean, if there are more questions from the audience, please go.
Yeah. So.
Is there more comment in the room? If not, I mean, we already have a very fruitful discussion that highlights the research data infrastructure and values and challenges. So has always been an ongoing effort globally. That's I don't know, I want to say pain of building commons, building like public infrastructures, but it's also high input, high reward effort. And I want to thank our panelists and all of our audience in the room for joining us. And we can give 5 minutes back to everyone and to grab some coffee.
Yeah, so thank you all for this session, and thank you for all the audience, the questions, and also the answers. So this session is finished, so please enjoy your coffee or something. And how about we take a picture together in the front floor to make a memory? Maybe this is the start of the AI piece. For the next session, we will meet in other countries. So please invite all of you to on the front. We take photo together. Thank you.